introduce you to some of the very key speakers. We're going to start with Chris Anderson. He's a very good friend of ours. We know him for quite a while. He has done some amazing stuff with 3D robotics, and he's the founder of DIY drones too as well. So I'm going to ask Chris to come on board here and continue the presentation. And by the way, Chris said he's going to have a better device than this in the future.
Very soon. We've been talking a lot about digitizing the world, and Carl Bass and I were talking the other day about, what are examples of really mass digitization of the world? Stuff that changes our life every day. So one of them is traffic, right? So Google Maps and Waze and things like that. Another is weather. There's things like air traffic, etc. But there aren't that many of them. How do we actually make this completely mainstream so it's the biggest big data opportunity anybody's ever seen? When you look at how Google did it with traffic, they did Street View. They had a bunch of cars traveling around, digitizing the world, and then they put apps in people's pockets, and those apps started to record where you were, and etc. And essentially, that's how we did it. So to Street View, what we need now is Sky View. The sky, weirdly, is empty. It's completely freaky. You look up there, there's like occasionally a jetliner that goes by. You go way up, there's satellites, but they're above the clouds and low resolution. But the rest of the sky is empty. And the reason it's empty is because you got to put people in. Typically, you got to put people in an aircraft. It's expensive and dangerous and all that, and highly regulated. But what if you took people out of the loop? Could you get sensors in the sky as densely as we have sensors on the ground? And the answer is yes, and I'm going to walk you through how that's working. So I'm going to tell you the story of how we as a drone company decided to expand into 3D scanning and 2D scanning company, and what it actually means to use drones as 3D scanners. So I'm going to start with where we were a few years ago. So this is typically what happens. You fly around a structure, you take lots of pictures, and then some software algorithm takes the pictures and tries to kind of figure out more or less where they are in space, and then stitches them together using the parallax effect to use the foreground and background, and then creates a 3D model, and the 3D model is kind of okay. Now this is a case where all we had was pictures, and then the software has to figure it out. And if the pictures aren't any good and the camera's not good, and the lighting wasn't good and the shadows weren't good, you end up with a pretty bad model. Now, then we started getting better. So then this is using a competitor to Autodesk. Then we started using the Autodesk recap engine. And this is, does anyone recognize this building, by the way? Anyone from San Jose? This is the Fry's in San Jose. So then we started using our own drones, and this is just flying around the structure with a GoPro camera and sending it up to the recap engine. And you can see it's starting to get pretty good. This is just a GoPro with a $700 drone with a one-button scanning button. It just goes around the structure twice. This is a building on the Google campus. These are pretty good. These are like photorealistic. They're the 90-degree angles and 90-degree angles. But what happened here? Now we're using this cement plant across from our building, and you can see it's not as good. And this is the problem with the real world. It's messy. It's got all sorts of weird shapes and curves and railings and weird lighting, etc. We can't just fly over things and expect to get a good scan. We need to get close. We need to get those cameras up. We need to have them look up. We need to have them look down. So I'm just going to walk you through how we did a better job of scanning messy stuff. So the way we started was, we said, for simple things, we'll just fly over it. Our app, this is the way you control a drone, by the way, it's an app. You just identify a structure and you tap on it. And then you tap on that and you say, scan this. And what it does is it creates this mission. It goes around twice and then it does this crosshatch pattern, and the camera looks down. Okay, so that's pretty good if you're pretty high and there's no telephone lines and there's no trees and all this kind of stuff. So it's good for simple stuff. But for more complicated stuff, when you want to get lower, you have to do something different. Now for that, we were inspired by Autodesk's 123D Catch app. And this is something that you can use on your phone, Apple or Android. And in this case, you take an object and use the camera phone, use the phone's camera, and you have to fill out these circles. So you go around and you take a picture, and then it fills it blue, and then you move, and then it coaches you to move to the next place. Then you take a picture, and ultimately you fill out those two circles, one low and one high, and then it sends those images up to the cloud and turns them into a 3D model. Now in this case, it's really guessing. It uses just the gyro and the phone to kind of figure out more or less where you are in the circle. But that's not good enough, because the real world is messier than that. The real world is not necessarily a circle, might not be the right shape. So the next analogy that we have is when you're using like a photosphere in Android, you know what it is. You start with the picture, and then it creates these circles, and it tells you, oh, go to, get the big ring around the circle. And so it moves you, it coaches you, it guides you to the next images with the right amount of overlap, so it can then stitch it together to create a perfect sphere. Now, okay, now you can see the way this is going. Now, there's enough intelligence on the phone, and it knows enough about the stitching algorithm to be able to guide you in real time. Now, the 3D modeling that we've been using, the recap engine, that's in the cloud. It's batch-oriented. You take 250 photographs, you upload them to the cloud, you wait 6 hours, and then you maybe get a model, or maybe you don't. Or maybe you get a model, but it looks like that one I showed you before. So how do we get smarter about this? How do we become more like the Android photosphere, where it's guiding you to the next image? So this is what happens. Drones used to be just a flying robot. Then that flying robot started talking to your phone, and now you've got intelligence on both places. You can run the same code on one and the other. That's a little bit better, and now that phone is connected to the cloud, and now we have the ability to connect the camera directly to the cloud. And now, in the same way that Android looks at the image and tells you which image to get next, we can start sending position and pose thumbnails up to the cloud. This is the vision. We're not quite there yet, but this is the collaboration we're working on with Autodesk. We can send a thumbnail and the metadata of the image up to the cloud, and the cloud could say, I got it. This is the next image I need to get the right feature overlap, to get the right foreground-background difference, so that I can start to extract the geometries. And this ability to finally make drones just a vector by which sensors connect to the cloud, and you can now load balance all this computational work between the onboard Linux computer, your phone's Linux computer, and the cloud's Linux computer, is how we're going to get the digitization to work really well, really fast. So what I'm going to show you is a little bit of a kind of a proof of concept of how this might work. So, actually, before I do, remember, this is the way, I'm going to actually go back a few slides. So remember the way it works here. You've got a lower circle and you've got an upper circle. Imagine you're going around a complex structure, and you, the human being, are the lower circle. You're walking around, and the drone is following you and taking pictures on the upper circle. And that's going up and down, and that it's basically like a pet robot bird. You walk around a structure, and the drone just follows you from above, taking the pictures of the right thing. Your job is to make sure the drone doesn't hit a telephone line or a tree. Your job is simply the safety officer. Your job is simply to walk around a building and not run into things. You're not doing anything. It's just your body. Actually, it's actually the phone in your pocket that's doing this. This is essentially your body's position. You are the controller. But all you're doing is walking around. All the rest is happening using follow me mode. The follow me mode basically uses your phone, it uses your Pebble watch or your Android watch as a display on this kind of thing, and it uses the GPS position of you and compares to the GPS position of the drone, and it just follows you around and becomes this 3D scanner. So I'm going to show you a little bit of how that worked. So here we are at that's me, and here we are. I am just walking around this really complicated, messy structure. And that's all I do. I walk around, I wear a hat, try not to get sunburned, and try not to hit anything. Now I'm just looking at my phone, making sure everything's working well, and you can see the drone is just following me around. Nobody's flying it. There is a safety officer in the back, but nobody's flying it. It's flying itself, and it's just basically referencing my position. So it goes up and down, and my job is just to go walk around the building a couple times. Okay, so that's pretty good. That's the view that it has. Now it's of course looking at that building there. Now, that's how we did it. I walk around and it follows me. Now this is what it was actually recording. So this is the data log that we re-render in this simulated first-person view. And as I was walking around the structure, this is what it's doing. It's doing these stacks. It's going up and down, taking pictures the whole way. It's got we told it the center of the building. We just tapped on the screen, the center of the building, and it tilts the camera up and down. When it's down, it looks up. When it's up, it looks down. And it's taking pictures the whole way, and that's how it scans the building. It did it all by itself, and it's optimized to get all the structure and all the different lighting variations safely without hitting things. Okay, so this is actually the shape of the structure. I walked around the building twice, and that's the path it did, creating these stacks along that path. And this is what we made, and here it is. Sandstone, 3D printed. This is what happens when a drone follows you around like a pet robot bird, scanning the world and turning it into something you can 3D print or put in your CAD file, snap into some existing digital workflow and see deltas, deviations. This is how we're going to scan the world, by making it so easy that you just walk around and the scanning works on its own. Now, where are you going to see this first? I think you're going to see it in construction. I think you're going to see it in architecture. You're going to see it in civil engineering, infrastructure. But I wanted to give you one last example of where it's being used right now. So you maybe heard that there was this terrible train accident. I think it was in West Virginia last week, and these tanker cars blew up, and it was due to a problem in the rail. So rail companies have a regulatory obligation to inspect their rail, and now after these tanker accidents, especially for these dangerous cargo, they have to inspect the rail more and more often. There's a huge amount of rail out there. There's something like, I don't know, 22,000 miles just for BNSF alone. And what if a tree has fallen over? What if a landslide has fallen over? What if a tie has become misaligned? What if there's a car, over? So this is what they're doing right now. They're using our drones to do track inspection. This is our Spectre, which you can see outside. It'll be flying in the net this afternoon. And they have this thing doing track inspection. Now you'll quickly see why trains and tracks are such a good way to a good thing to digitize. Because it's like the perfect computer vision problem. It's like these parallel lines with these perpendicular lines, and it's so easy to see if there's something obstructed here. The bridges are also known objects. It's easy to spot those as well. And this is the low-hanging fruit for digitizing the world, is simply using these things either ahead of the train, on regular areas. These are the tanker cars, being able to spot these problems. We have autonomous rovers on the ground as well. They're using ultrasonic sensors to look more closely at the rail. And this is how we maintain the safety, integrity of our infrastructure, is not by having humans out there, looking ahead of every train, or not by taking risks, or not by going slow. It's by using automation, by using digital information to spot this stuff safely, often, and in high resolution, so that humans don't have to do it. Thanks very much.
Thank you, Chris.